Late 1930s. The German military had been observing the development of remote-controlled vehicles with great interest. The concept wasn't entirely new. Remote-controlled boats had been experimented with as early as World War I, and various nations had toyed with the idea of unmanned demolition vehicles. The direct inspiration for the Goliath came from an unlikely source: a French prototype. In 1940, during the invasion of France, German forces captured a French remote-controlled vehicle called the Congress tracked mine. This small demolition vehicle had been under development by engineer Adolphe Congress, but had never entered production. The Germans were immediately intrigued by its potential. German military engineers saw several potential applications for such a device. First, it could be used to clear minefields and barbed wire obstacles that would otherwise require sappers to risk their lives. Second, it could destroy fortified bunkers and defensive positions from a safe distance. Third, it could be employed as an anti-tank weapon, driving under enemy vehicles and detonating to destroy them. Finally, it could demolish bridges and other infrastructure without exposing demolition teams to enemy fire. The timing was particularly opportune. As Germany prepared for Operation Barbarossa, the invasion of the Soviet Union, military planners anticipated encountering heavily fortified defensive lines. They wanted every tactical advantage they could develop. The concept of the Goliath fit perfectly into this strategic thinking. Development of the Goliath began in 1940 under the auspices of the German Army Ordnance Office. The project was assigned to two companies: Borgward, which would handle the overall design and production, and Zundap, which would develop the propulsion system. Carl F. W. Borgward, the company's founder, was already well known for his automotive innovations, and his company would become the primary manufacturer of these unique weapons. The first production model, designated Leichter Ladungsträger Goliath SDK-FC 302, began rolling off assembly lines in 1942. This initial version was electrically powered, which created both advantages and significant limitations. The electric motor was quiet, which was tactically beneficial, and relatively simple mechanically. However, it also meant the vehicle needed to remain connected to a control unit via cable, which limited its operational range and created vulnerability. Let me describe the physical characteristics of this machine. The Goliath SDK-FC 302 was surprisingly small, only about 150 centimeters long, 85 centimeters wide, and 56 centimeters tall. It weighed approximately 370 kilograms, which included its explosive payload of 60 kilograms. The vehicle ran on two electric motors, one for each track, which allowed for steering by varying the speed of each track independently, the same principle used in modern tanks. The control system was ingeniously simple for its time. An operator would use a control box connected to the Goliath via a three-conductor cable that could extend up to 650 meters. The control box had basic functions: forward, reverse, left turn, right turn, and detonation. The cable was wound on a spool within the Goliath itself, which unwound as the vehicle moved away from the operator. This was both the system's greatest strength, allowing operators to remain at a safe distance, and its greatest weakness, as we'll discuss later. The electric version had significant shortcomings that became apparent during field testing and early combat use. The batteries were expensive to produce, the vehicle's speed was limited to about 6 kilometers per hour, and the range was severely restricted. Perhaps most critically, the cable trailing behind the vehicle was highly vulnerable to being cut by artillery fire, small arms fire, or even just the chaos of the battlefield. These limitations led to the development of an improved version, the SDK-FC 303. This variant, which entered production in 1943, replaced the electric motors with a small two-stroke gasoline engine. This single-cylinder engine, developed by Zundap, gave the Goliath significantly better performance. The new version could carry a larger explosive payload, 100 kilograms instead of 60, and could achieve speeds of up to 12 kilometers per hour. It was also cheaper to produce, an important consideration as the war increasingly turned against Germany. However, the gasoline-powered version still used a cable for control, which meant it retained one of the fundamental vulnerabilities of the electric model. The cable for the SDK-FC-303 was slightly different in design but still limited the vehicle's effective range and remained susceptible to damage. Production of the Goliath tracked mines continued from 1942 until the end of the war in 1945. Approximately 7,500 units were manufactured in total, with roughly 2,600 being the electric SDK-FC-302 model and about 4,900 being the gasoline-powered SDK-FC-303 variant. These numbers might seem impressive, but they represented a relatively modest production run compared to other German weapon systems of the period. The shift from electric to gasoline power wasn't just about performance. It was also about resources. As the war progressed and Germany's economic situation deteriorated, the expensive batteries required for the electric version became harder to justify. The gasoline engine, while louder and somewhat more complex mechanically, was ultimately more cost-effective to produce at scale. There were also experimental variants that never entered mass production. Engineers explored the possibility of wire-guided versions that would eliminate the vulnerable cable, radio-controlled models that would provide even greater range and flexibility, and versions with different explosive payloads for specialized missions. However, the increasingly desperate military situation and Germany's dwindling resources meant that most of these innovations never progressed beyond the prototype stage. So how were these machines actually used in combat? The Goliath tracked mines were organized into specialized units called Panzerabteilung ZBV, or Special Purpose Armored Detachments. These units were trained specifically in the deployment and operation of the remote-controlled mines. Each unit typically had multiple Goliaths, along with transport vehicles, control equipment, and trained operators. The tactical doctrine for Goliath deployment was relatively straightforward in theory, though considerably more complex in practice. Operators would position themselves at a safe distance from the target, typically in cover or a defensive position. They would then guide the Goliath toward its objective using the control box, steering it around obstacles and toward the target. Once in position, they would trigger the detonation. The Goliath saw action on multiple fronts. They were deployed on the Eastern Front against Soviet forces, in Italy during the Allied advance up the peninsula, on the Western Front following the D-Day landings, and in various defensive operations as German forces retreated. Each theater presented unique challenges and revealed both the strengths and weaknesses of this unusual weapon system. One of the most famous uses of Goliaths came during the defense of Anzio in Italy in 1944. German forces used the tracked mines in attempts to destroy Allied tanks and disrupt beachhead operations. The results were mixed. Some successful detonations occurred, but many Goliaths were destroyed before reaching their targets or had their control cables severed by defensive fire. During the Normandy campaign, German defenders had prepositioned some Goliaths in defensive emplacements, intending to use them against Allied landing forces. However, the chaos of the invasion, combined with the effectiveness of Allied naval bombardment and air superiority, meant that most of these weapons were destroyed before they could be deployed effectively. Allied soldiers who encountered Goliaths often reported that they were more curious about these strange devices than threatened by them. The reality of battlefield conditions often worked against the Goliath's effectiveness. The control cable was extremely vulnerable. A single bullet or shell fragment could sever it, leaving the Goliath immobilized and useless. The vehicle's slow speed meant it took considerable time to reach targets, during which it was exposed to enemy fire. The small tracks sometimes struggled with rough terrain, mud, or obstacles, limiting where the Goliath could be effectively deployed. Moreover, the psychological impact worked both ways. While some Allied soldiers were initially surprised or concerned by these unmanned vehicles, they quickly learned that destroying them was relatively simple. Machine gun fire could damage the tracks or penetrate the thin armor. Artillery fire could easily destroy the vehicles. And in many cases, simply shooting the control cable was enough to neutralize the threat entirely. Let's take a moment to recap the technical specifications of both major variants, as these details help us understand both the capabilities and limitations of these machines. The SDK-FC-302, the electric version, measured approximately 1.5 meters in length, 0.85 meters in width, and 0.56 meters in height. Its combat weight was around 370 kilograms, including a 60-kilogram explosive charge. The two electric motors provided a maximum speed of 6 kilometers per hour, with a practical range of about 1.5 kilometers limited by cable length. The armor was minimal, just 5 to 10 millimeters, sufficient only to protect against small arms fragments and shrapnel. The SDKFZ-303, the gasoline-powered variant, was slightly larger and heavier at approximately 430 kilograms combat weight. It carried a more substantial 100-kilogram explosive payload. The Zundap two-stroke engine gave it a maximum speed of 12 kilometers per hour, though cable length still limited practical range to about 1.5 kilometers. The armor protection remained similar to the electric version. Both versions used a simple track system without suspension, which made them relatively uncomfortable to operate remotely and limited their ability to traverse rough terrain at speed. The lack of sophistication in the control system meant operators needed line of sight to their targets and had to maintain visual contact with the Goliath throughout its run. What made the Goliath concept innovative, and what prevented it from being more successful? Let's examine both sides of this equation. The primary advantage was obvious. It removed soldiers from immediate danger when delivering explosives to a target. In an era when demolition work typically required sappers to crawl forward under fire to place charges manually, the ability to do this remotely was genuinely revolutionary. The Goliath could theoretically approach targets that would be suicide missions for human soldiers. The explosive payload, particularly on the later gasoline version, was substantial enough to destroy most targets. 100 kilograms of high explosive could demolish a bunker, destroy a tank, or blow a significant gap in defensive obstacles. The shaped charge versions could be particularly effective against armored vehicles if they could get underneath them. The small size and low profile of the Goliath made it a relatively difficult target, at least in theory. In terrain with good cover or at night, a skilled operator might be able to guide the vehicle to its target without it being spotted immediately. The quiet operation of the electric version enhanced this stealth potential. However, the weaknesses were numerous and significant. The control cable was the Achilles heel of the entire system. Trailing behind the vehicle for hundreds of meters, it was extremely vulnerable to being cut, damaged, or tangled. Once severed, the Goliath became nothing more than an expensive stationary bomb that could potentially be captured and examined by enemy forces. The slow speed was another critical limitation. At 6 to 12 kilometers per hour, the Goliath took considerable time to reach targets, especially over any distance. This gave defenders ample opportunity to spot the vehicle and either destroy it or shoot its cable. The time factor also made the Goliath unsuitable for rapidly evolving battlefield situations. The lack of sophisticated guidance was problematic as well. Operators needed line of sight to effectively control the vehicle, which often meant exposing themselves to observation and fire. There was no camera system, no sophisticated telemetry, just visual control by an operator who had to keep the Goliath in view. This severely limited the tactical situations where the weapon could be effectively employed. The thin armor meant that almost any weapon could destroy a Goliath. Heavy machine guns could penetrate the armor and destroy the internal mechanisms. Artillery or mortar fire that landed anywhere near the vehicle would likely destroy it. Even hand grenades could be effective if thrown accurately. Finally, there was the cost-effectiveness question. Each Goliath was expensive to produce relative to its single-use nature. Once deployed and detonated, or destroyed, that investment was gone. When you consider that many Goliaths were destroyed before reaching their targets, the cost-benefit ratio becomes questionable, especially for a nation that was increasingly short of resources as the war progressed. How did Allied forces respond to this unusual weapon? The initial encounters produced surprise and curiosity. Soldiers who first saw these small tracked vehicles weren't quite sure what they were looking at. Reports from the field described confusion about whether these were some kind of remote-controlled observation vehicle, a new type of robot tank, or an explosive device. Once the nature and purpose of Goliaths became clear, Allied forces quickly developed countermeasures. The simplest and most effective response was to target the control cable. Infantry were instructed to watch for the telltale cable and to cut it with gunfire or even hand tools if possible. This simple measure could neutralize a Goliath before it posed any real threat. Tank crews were warned about Goliaths and instructed to watch for them, particularly in urban combat or when advancing through areas with limited visibility. Machine gunners were told to engage the vehicles on sight. Artillery and mortar crews learned that these were high-priority targets worth immediate fire. Intelligence officers were very interested in captured Goliaths. The Allies conducted detailed technical assessments of captured vehicles, analyzing their design, capabilities, and limitations. These assessments helped in developing both countermeasures and in understanding German technological developments more broadly. Some Allied nations even considered developing their own versions, though none entered production during the war. The psychological impact was minimal once soldiers understood what they were facing. Unlike some other German weapons that inspired genuine fear, the Tiger tank, the V-2 rocket, the Goliath was more of a curiosity than a terror weapon. Its limitations were obvious, and Allied soldiers quickly learned it was more vulnerable than threatening. Despite its mixed combat record, the Goliath track mine holds an important place in military history. It represented one of the first serious attempts to develop a practical unmanned ground combat vehicle. While the technology of the 1940s couldn't fully realize the vision, the concept itself was sound and pointed toward future developments. In the decades following World War II, military forces around the world continued to explore remote-controlled and unmanned vehicles. The lessons learned from the Goliath, both its successes and its failures, informed these later developments. The fundamental problems that plagued the Goliath, control range, vulnerability, guidance precision, became the focus of technological research. The development of radio control technology in the 1950s and beyond addressed one of the Goliath's primary weaknesses. Without a physical cable connecting the vehicle to its controller, unmanned vehicles became far more practical. The addition of onboard cameras in later decades eliminated the line-of-sight requirement that had limited the Goliath's effectiveness. Today's military unmanned systems, from small ground robots used for explosive ordnance disposal to sophisticated drones, are the direct descendants of concepts first explored with vehicles like the Goliath. Modern EOD robots can approach and investigate suspicious packages or improvised explosive devices, removing humans from immediate danger. Armed drones can strike targets from vast distances with precision that was unimaginable in the 1940s. The Goliath also serves as an interesting case study in military innovation and the gap between concept and execution. The idea was brilliant for its time, but the available technology couldn't fully support the vision. This is a recurring theme in military history. Innovations that are ahead of their time, waiting for technology to catch up. From a historical preservation standpoint, surviving Goliaths are now rare and valuable artifacts. Museums around the world display these vehicles as examples of World War II technology and innovation. They serve as tangible reminders of how military forces sought to solve tactical problems through technological means, even when the solutions proved imperfect. The Goliath tracked mine represents a fascinating chapter in military technological development. It was an innovative solution to real tactical problems, combining explosives with remote control in a way that prefigured modern unmanned systems. However, it was also a weapon that never quite fulfilled its promise, hampered by technological limitations and battlefield realities. The approximately 7,500 Goliaths produced during World War II achieved some successes but failed to become the game-changing weapon that German military planners had hoped for. The vulnerable control cable, slow speed, thin armor, and limited guidance capabilities meant that these vehicles were often more effective as propaganda or psychological warfare tools than as practical weapon systems. Yet we shouldn't dismiss the Goliath as a failure. It represented genuine innovation and creative problem-solving. The engineers and military planners who developed it were thinking ahead, envisioning a future where unmanned systems could remove soldiers from danger while still accomplishing necessary military objectives. They were simply working with 1940s technology to realize a vision that required 21st-century capabilities. Today, as we see increasingly sophisticated unmanned systems deployed in military and civilian applications alike, it's worth remembering these early pioneers. The Goliath tracked mine, with all its limitations and quirks, helped establish concepts and identify challenges that later generations would build upon and eventually overcome.